Hello everyone, welcome back. Today we're going to learn the basic of Wireshark. So Wireshark is a network analysis tool. Okay, so it is used for analyzing network. It is used for troubleshooting, like if there is a slow latency, if there is any problem in the network, then with the help of Wireshark we can analyze it. And it is used for security analysis also. If there is any malicious activity in the network, that we can use the Wireshark and we can find it. Okay, so before jumping to the Wireshark, doing it practically, let's learn something that we are gonna need in our Wireshark. So one is source IP. Source IP is basically where the packet is coming from. That is for your electronic device, that is your PC, your phone, and destination IP is where the packet is going. So example, a website. So basically if you are visiting a website, visit instagram.com, then the IP of instagram.com is the destination IP. Another is port. So port are like a door on a computer. They tell the system which service should receive the data. So think of it as IP is to identify devices, right? So port identifies what application is being running on the service, right? So think of it as IP as an apartment, and apartment, a street name or apartment, and port and as a apartment ID. Okay, apartment ID. Yeah. So port hierarchy is like in one packet there are many protocols using a different kind of ports. So some ports are reserved for specific services. There are thousands of ports, but we are gonna need only some of them. So HTTP, which is Hypertext Transfer Protocol, is uses port number 80. HTTPS, which is a secure version of HTTP, uses 443. File Transfer Protocol uses 21 and 22. Domain Name Server uses 53. SSS uses 22, and Simple Mail Transfer Protocol uses 25. Okay, these are the basic things that we are gonna need before jumping to Wireshark. Okay, now let's go to our Wireshark. So once we go to the Wireshark, this is your interface. Okay, so you'll see different kind of things you can choose, different kind of filters you can choose, right? So it depends upon your operating system. So I'm in my Linux machine, so I have a different interface. If you're in Windows or Mac, you might get a different interface, but the work is same. Okay, now let us go before jumping to the Wireshark, let us understand what are this interface. So if you are in Linux, do if config, right? And if you are in Windows, do IP config. So do if config. So this is ENP2S0. This is a Ethernet interface. So if you are connected to a Ethernet, then you will see an IP. So you'll see an IP, and you can capture the flag of that Ethernet. Okay, and this is allo. This is allo is a loopback running. So if you're in Linux, you can see this. So this is basically used by internal services used to communicate within themselves. So this is not much. So if you are using a VPN, you will see a VPN. So I'm using a Proton VPN. So this is my Proton 0 is my VPN, right? So if you're using different kind of VPN, like there will be TUN0, which is an open VPN, right? And you might also see WC0, which is an WireGuard VPN. Okay, so and this WL12S0, so this is the most used interface. So this is a wireless interface that if you're connected to a Wi-Fi, right, you will get an IP. So with that IP, you are gonna capture a flag. So basically you're gonna work on that. So these are the interface, these are the packet that you're gonna do. So I'm gonna go. So okay, let's quickly go to the overview of a Wireshark. So if you're gonna set your own profile, like I'm gonna use the default, but if you wanna do that, just press on the Wireshark, default, go to then click on the right, do a right click and go to a manage profile or a new. So with new, you can add a new profile and start using a Wireshark, but I'm gonna do in default. Okay, so now depending upon which Wireshark or which version of Wireshark, you will have a toolbar. So if you're in Windows or Mac, then you might get a Wireshark as a toolbar, and once you go there, you'll find a preference. As I'm in my Linux, I get preference in my edit edit bar. Okay, so this is an overview of this is how you want to customize your Wireshark. So column, it is used to set where do you want to set your, suppose these are the Wireshark information that I'm going to get inside once I start capturing a packet. So if you want the time to be at last, you can keep on the time last, but I want it to be in a second, so I have kept it at a second. Okay, so you can customize all these kind of things at a column. So this is the font color. This is especially for the display filter. Okay, so if it turns to green, it is a valid filter. If it turns to red, it is a invalid, and if it turns to yellow, it is a warning. So this is a layout. So if you are using a new version of Wireshark, then you'll find this. So basically they added a new thing called a packet diagram. So if you press on this and you'll get a error version of this packet. Okay, so we will use this, but I'll go back to my packet bytes later on. Okay, so now once you do that, now I'm in my default, right? So what I'm gonna do is I'm gonna use gonna capture from my VPN. Okay, so look, this is what you get, a error version of a packet once I selected a packet diagram, but I don't want this. I want it to my packet bytes. So okay, I do this. So okay, immediately once I started my Wireshark, I started getting packets, right? So it started capturing a bunch of packet. So what we're gonna do today is we are gonna learn how to capture 3 packets, which is TCP, UDP, and HTTP, which are very basic protocols. So TCP is a transmission control protocol. Okay, it is a connection oriented protocol. It is very reliable. It guarantees the packet to be delivered, and before sending a packet, a three-way handshake, with the help of three-way handshake, a connection is established. So what is a three-way handshake? So imagine a sender and a receiver are there, and sender sends a synchronization packet, and a receiver sends a synchronization with acknowledgement packet, and a sender receives an acknowledgement. This is a three-way handshake. For a simple analogy, understand it as a sender wants to communicate with the receiver, right? So sender says, hi, I want to talk to you. Once it sends the message to a receiver, receiver replies back is saying, okay, I am free, let's talk. Then after that, a sender receives again to the receiver, replies back saying, okay, now let's have a conversation. So this is basically a three-way handshake. After establishing a three-way handshake, then only a connection is established. So we are gonna capture a three-way handshake, which is a TCP. Okay, first this is our display filter, and we are getting bunch of packet. You'll captured each and every packet, so it is very hectic to find your particular packet. So in order to do that, we'll use our display filter, which is TCP, right? If I capture a TCP packet, I'm just gonna do a TCP, and I'm gonna get a TCP packet, right? So what we are gonna do is, first we'll go to our okay, let's go to our browser, right? So once you go to our I'll go to my example.com and google.com. okay, so once I go back, I'll go to my Wireshark. So I want to capture a TCP filter, so let's do a TCP. You can write a TCP, you'll get all the TCP filters. Okay, so TCP packets. So first what we are going to do is we're going to see the IP address of our, so what we search. So we if you want to see, if it works for every website, right? It is the Linux command. So if you do ns lookup google.com, you'll get the IP of a google.com, you'll get the IP of the google.com. And similarly, once you do this for example.com, which we browsed our web browser, right? So we'll get a so this is our destination, I mean this is the IP of our website that we searched for. Okay, this 127.0.0.53 is our local TCP resolver. We're gonna talk that in our UDP part. So once I do that, now I want to capture a synchronization flag first, right? So what I'm gonna do is TCP dot, what I'm gonna do is flags, right? FL is flag dot sync equals to 0 at the end, and TCP dot flag okay, what I'm going to do is I'm going to type it, okay, dot synchronization flags dot SYN equals to want my synchronization to be up. So once a sender sends to a receiver, is gonna be up, right? And once it goes up, it is equals to 1. And what I'm gonna do is, so and TCP dot FLAGS flags dot acknowledgement should be 0. So okay, TCP dot flag acknowledgement equals to 0. So wait, I did some mistake over here. ACK equals to 0. I think this should be synchronization SYN. My bad, it's a spelling mistake. So okay, so this, once it is valid, now what you captured is, this is the IP that, these are the packets that you captured, which is synchronization packets. So once so we know that the IP of a Google is 142. So once you open this packet, you're gonna get a frame, you're gonna get a IPv, you're gonna get a TCP. Once you click on TCP, you're gonna get a lot of things. You're gonna get a sequence number, you're gonna get a port, source port, destination port, everything, the flag, what is being used. So you're gonna get everything over here. So this is basically you are capturing of a Google, right? And now what if I want to capture a flag of a three-way answer flag, that is a synchronization plus acknowledgement. So what we're gonna do is, we're gonna just make this and 1, right? This is for a synchronization and acknowledgement, which receiver sends to a sender. Okay, so once you do that, now our source IP is our website website browser that we visited. So we know that 142 is for Google IP, right? So this is the Google IP that is coming from and to us. So this is the synchronization acknowledgement flag that you just captured, and here you can see everything that we saw on synchronization flag. So synchronization and SYN. Okay, so what we're gonna do is, now we're gonna capture for acknowledgement. For that, what we're gonna do is, we're gonna make synchronization 0 and acknowledgement 1. So we only want the packet, the handshake that was sender sends to a receiver, right? So once you do that, you get this. So what we got is a package which was sent, which was of acknowledgement and SYN. Okay, so once you click on any packet, like you get the same windows, you get a segment number, you get a frame number, source port, everything of this packet, which is of a flag acknowledgement. Okay, so this is how you captured a TCP flag. So once you do that, there are multiple other ways that you can capture, like TCP dot port equals to 53. So 53 is port of a DNS. So if there is any TCP that is using a DNS, so you can capture a flag over here. So this is how you do for TCP. Now let's move to a DNS. Okay, so UDP. So UDP is a user datagram protocol. Okay, so it is a connectionless protocol. It doesn't have a three-way handshake like a TCP does. It doesn't guarantee a packet delivery. It just delivers a packet, but it doesn't take the guarantee of a packet delivery successfully, right? So it is unreliable. It is basically used, it is mostly used in online gaming, video calling, live streaming, like that. Okay, so another important of UDP is that it is used in DNS. DNS uses UDP port 53 to communicate. Basically, like we did here in our terminal, like nslookup.google.com, right? So and we're getting the IP, right? So this is basically happening through our UDP port 53 of a DNS using a port 53 of a UDP. Okay, so if you want to search UDP packets, just type UDP, right, and you'll get a UDP packets. Okay, now let's see how it is, how DNS uses UDP port 53. Now for that, in our display filter, do UDP port equals to 53. You will get a bunch of packet which is using UDP port equals to 53. So you might get a little bit confused because the source IP and destination is same, right? Why it is same? Because I'm in Linux machine and Linux uses local DNS resolver, which is 127.0.053. okay, so it uses this. So what happens is, if I go to my browser, right, and I search for something, my browser sends a special request to my DNS local reserver, and my DNS local reserver sends a special request to a real DNS reserver on the internet, okay, I mean server on the internet. So that's why the source IP and the destination IP is the same. So, just use the info section, which here you can differentiate, like www.google.com. Now once you go to that particular packet, you will see a frame, you will see a IP, which IP you is using, you will see a user datagram protocol, and you will see all the destination port, source port, right, the checksum and the timestamp, right. And once you go to a domain name system, go to the query, right, and once you will see a flag, you will see a transaction ID, everything, and go to the query, you will see the host, which is www.google.com. so this is where we are getting a reply from www.google.com. so once you do that, now if you want to capture a real real traffic, real DNS traffic, not a local reservoir, you can search real traffic by DNS and not equal to ip.dst destination, which is equals to 127.0.0.53, basically the local reservoir IP. okay, once you do that, you will get still, if you are still getting the source IP and destination IP the same, then that means your DNS is using encryption method. So if you're getting a different IP, then well, that's your real traffic, real DNS traffic IP, okay, I mean real DNS traffic. So sometimes what DNS does is it uses a TCP. So if you want to check if your DNS is using some kind of encryption, then just do DNS TCP dot port equals to 443. Here okay, TCP dot if you just do that, and you're getting a reply, right. So if you're getting a packet, that means it is using a DNS filter, which is basically using a DNS it is using a DNS encryption method, which is of a DNS over HTTPS, which is DOS, which is also known as DOS. So it is using an encryption. If you are getting a different, I'm getting a different source IP and destination IP, as you can see, that means it's not using HTTP, or it might be using a different TLS, which is a port address of 800 something. You can check it clearly that, but I'm getting so this is my real DNS, okay. So now as UDP is used on a live streaming, that means YouTube might also use a UDP, right. So but YouTube doesn't only use UDP, it uses a QUIC. So let us see go to the YouTube, okay. So once you go to the YouTube, and what I'll do is I'll start my Wireshark, once I go to my browser and I go to my YouTube and start playing a video, right. So if I start playing a video, then we must capture the continuous flow of a video being played, okay, in our Wireshark. So this is the most. So if I play any video, right, it can be any video. I just okay, so so go to your Wireshark. So if you can just play the video for get, okay, it can be just for a short amount of time, okay. So you do UDP, so once you do that, okay, so here you can see a QUIC being played, right. So this is the amount of time this is the Wireshark captured when your video was being played. Okay, so why does UDP just use the UDP normally? Because UDP has no encryption, okay, and QUIC is a UDP but with the additional feature. It is built over the UDP. So QUIC adds the additional feature like encryption, congestion control, which UDP lacks, right? And UDP also and QUIC also has the encryption TLC, which is a translation layer security, which is used for security purposes, and a network congestion control. So for this reason we use QUIC, and you do not get confused if you're capturing a QUIC over a UDP. QUIC is a UDP built over a UDP. Okay, so this is the UDP IP. If you go here, you can check from here QUIC. This is QUIC. This is the packet that we captured, right? And you can get all the additional information, the amount of time that it has been seen, length, there is a timestamp, there is everything. So there's basically everything. So this is how UDP YouTube use a protocol in its video. So now next is HTTP. So HTTP, as you know, hypertext transfer protocol is not as secure. It is not a secure protocol. It is used in a website, but it is not a secure version. So why it is not a secure version? Let's quickly see that as well. Okay, so what I'm gonna do is I'm gonna restart my capturing of a packet. Okay, capturing of a packet. So if I come to demo.test.fire.net, so once I demo.testfire.net. so see, as you can see there is HTTP. It is using HTTP protocol. So once it is using HTTP protocol, we can test how HTTP is secure or not. So here what I'll do is I'll go to a sign in. Once I go to a sign in and see here, my Wireshark is capturing packets, right? It's generating a packet. It's capturing a packet. I'll go to a web browser and I'll write a text. Text. Okay, I'll write a username text and 1234 as my password, or 5. Okay, 12345 is my password. I'll do my login, right? So okay, wait a minute. I'll again do test and I'll do 12345 as my password, and I'll do a login. So there's a important concept in HTTP about a get and a post. So get is to get an information, and post is generated when you do a login. So basically, when you go to a Wireshark, okay, once you go to a Wireshark, if you type HTTP, you'll get a bunch of packet that is using a HTTP, okay, HTTP protocol. So here what you can do is see the get. Once you see the get, open that, you'll get the frame, internet protocol, transmission, everything. You'll get a flag, everything. And once you go and you will see a hypertext transfer protocol. Once you click on the hypertext transfer protocol, what you're gonna do is this is when you open the website, right? This is when you open the website, when you open the website for a sign in. So this is basically when you're getting in sign in. So here what you want to see is, when you have to see is the post. Once you see there is a post, if you're having difficult time for getting a post, what you can do is do http dot in a display filter, okay, do request dot method, okay, method equals to what you can do is post. Okay, so once you do this, you'll get a post. So like I said, post is generated when you press a login, so in a HTTP. So once you click that, you'll get everything the same. Go to scroll down and you'll see a hypertext transfer protocol, and expand that and expand the post one. Okay, so once you post that, you'll see everything. You'll see which web browser we are using, which operating system we are using, C Linux, C Mozilla Firefox. And once you do that, go to your HTTP from URL encoded. Once you go there, here you can see your UID, which is text, which is 12345. This is your password and this is your login. So this is the reason why HTTP is so unsecure, so unsafe. This is the reason why we have to use HTTPS. So these are the basic protocol that that you can search in a Wireshark. There are multiple of them, but this is very basic. So I hope it has been helpful for you. So see you all in our next video. Okay.